Okay, question 8. Which of these is a scalar quantity? So it only has a size, it does not have a direction. Acceleration, that's a vector quantity. Distance is a scalar, but I'm just going to have a double check. Force, vector. Weight is a force. So same thing, they're both vector quantities. So the answer is B, distance. Next one, students got some cupcakes, cupcake cases. You can see one there, there's a picture. They're going to drop the cases with the base facing downwards. And they say the speed of the falling stack depends on the number of cupcakes. Okay. The student has a stop clock and a meter ruler. And it says describe an investigation. So then after you explain in the trend or what's going on, it's describe what investigation you'd do. So if here's our cupcakes, I'm going to, and there's the floor, I'm going to measure a height with a ruler. I'm going to change the number of cases, 1, 2, 3, 4, 5, 6. I'm going to state I want at least 5 in the range. So let's go to 1 to 8 cases. I'm going to time it, and speed equals distance over time. That's everything that I need to talk about. But it's that describe an investigation. It does not ask you to predict what's going to happen. So measure a set height using a ruler. Change the number of cases, e.g. Obviously 0 cases. I don't drop anything. 1, 2, 3, 4, 5, 6 cases. Time the fall with the stop clock, and speed equals distance divided by time. Next one, we've got a question on weight. So that's the My Wrinkly Gran. And a stack of cupcakes has a mass of 0.05 kilograms. Perfect. That's the unit I want it to be. Calculate the weight, and it tells you the gravitational field strength is 10. So I've just got to copy that, and it's multiply that beauty by that beauty. Wish I'd said that before. Repeat 3 times above. So now we're ready. 0.05, 0.5 times 10 equals 0.05. Really easy question. That's a give me that. On to the next one. Got a cupcake that is falling at a constant velocity. Okay, so that means that the forces are balanced because it's moving at constant speed. Draw an arrow to show air resistance on the cupcake. So you need an arrow up. And I've made a bit of a bodge. If it's going at a constant velocity, that really should be the same size as well. So it needs to be an arrow that's the same size because it's moving balanced. So there we go. Ignore that one. Boo, that's horrible. Look at the other one. Woohoo, that's lovely. State the value of the acceleration. Well, it tells you it's moving at a constant velocity. There is no acceleration. And so the value must be 0 meters per second squared. And then the next one, a car travels along a straight road. They accelerate at 3 meters per second squared. Beautiful. Don't need to change it. 4-7 seconds. Gorgeous. Don't need to change that either. Calculate the velocity, and it tells you how to do that. All right. So this is really, we know that we've got, if I just quickly go through, A equals V minus U over T. This is a simplified version of me then rearranging for V. V equals, well, I'm going to times both sides by T. So that T is going to go up there. A times T. And then I've got minus U there plus U. And you can see that that's where this comes from. And because there's no initial, it becomes V equals AT. But all you've got to do is follow exactly what it says. A times T. Multiply those numbers together. 21 meters per second. But I've just tried to explain it with a bit of maths on the side.